So hello everyone, it's me Apurv Gaurav, USN 1VE23IS006, semester 3rd, course Data Structures and Application, course code BCS304, Department Information Science and Engineering. So today's my topic is Introduction to Static Hashing. This presentation explores the fundamentals of static hashing, a fundamental technique used for efficient data storage and retrieval in computer science. What is static hashing? Static hashing is a technique for organizing and storing data in a way that allows for quick and easy retrieval. It involves mapping keys to unique addresses within a fixed size table. The table is known as hash table. When you want to access a specific data item, you simply calculate its hash value and then use that value to locate the data item in the table. Key components of static hashing: hash function, hash table, collision handling. This function takes a key as input and generates unique hash values. Hash table, a fixed size data structure that stores the data items. Collision handling, a strategy to deal with situations where multiple keys map to the same address. Hashing function and their importance. First, efficiency. Second, uniformity. Third, security. A good hash function ensures that keys are distributed evenly throughout the hash table. Uniformity, it reduces the likelihood of collisions, leading to faster data access. Third, security. Cryptographic hash functions are used in security for integrating authentication. Collision handling techniques. Separate chaining. A linked list is created at each table location to store multiple items that map to the same addresses. Open addressing. If a collision occurs, the algorithm probes for an empty slot in the table using a specific function. Advantages of static hashing. First, fast retrieval. Second, efficiency. Third, simplicity. Allows for constant time average case lookup. Reduces time spent searching for data. Easy to understand and implement. Limitation of static hashing. First, fixed size. Second, collisions. Third, memory usage. The hash table size needs to be determined in advance. If the data size increases, the table might need to be resized. Collisions. Collisions can occur which can slow down data retrieval. Memory usage can be inefficient for storing sparse data, and many slots in the table are empty. Application of static hashing. Databases for efficient indexing and data retrieval. Second, routers for packet forwarding based on destination addresses. Third, search engines for indexing web pages and retrieving relevant search results. Comparison to other hashing methods. Performance. Static hashing offers excellent performance for fixed size datasets, but it might struggle with dynamic changes. Memory usage. Dynamic hashing can optimize memory usage while shrinking the hash table as needed. Conclusion and takeaways. Static hashing is a powerful and versatile technique that plays a critical role in numerous computer science applications. An ability to provide fast and efficient data retrieval makes it a valuable tool for optimizing various data storage as processes. So hello everyone, welcome to my YouTube channel. It's me Apur Gaurav and today's my topic is Introduction to Static Hashing. This presentation explores the fundamentals of static hashing, a crucial data structure that plays a vital role in numerous computing applications. What is hashing? Key concept. Hashing is a process that converts data such as text or number into a fixed length hash value. Uniqueness. This hash value acts as a unique identifier, making it easier to store, retrieve, and compare data efficiently. Hash functions and collisions. Hash functions. Hash functions are algorithms that generate hash values from input data. Second, collisions. Collisions occur when two different input values generate the same hash value. These are unavoidable. Third, collision handling. Efficient collision resolution techniques are essential for maintaining the performance of hash tables. Static hashing concepts. Fixed size. Static hashing utilizes a hash table with a fixed size, making it suitable for situations where the dataset size is known beforehand. Key value pairs. Data is stored to key value pairs where the key is used to calculate the hash value and the value is the actual data being stored. Direct access. Static hashing allow for direct access to data by using the hash value into the hash table. Hash table. Data structure. Hash tables are a data structure that uses hashing to organize data for efficient access. Keys. Keys are the used to calculate hash value which determine the location of data in the table. Speed. Hash table offer the fast average case performance for operation like searching, insertion and deletion. Collision resolution techniques. First, separate chaining. This approach uses linked lists to store data elements like collide, allowing multiple elements to share the same hash index. Open addressing. This method involves searching for an empty slot within the hash table when a collision occurs, using probing techniques to find an alternative locations. Choosing the right technique. The selection between chaining and open addressing depends on the as expected dataset size, collision frequency, and performance efficiency. Chaining versus open addressing. Chaining. Simple to implement, efficient for high collision rate, requires more memory for a linked list. Open addressing can be more complex, may experience performance degradation with high collision rates, requires less memory. Advantages of static hashing. Fast access. Provide constant time average case performance for lookup, insertion, and deletion operations. Efficient search. Enable quick retrieval of data elements by directly accessing the hash index. Third, optimal performance. Offers high performance in situations where the data set relatively stable and collisions are minimized. Limitation and drawbacks. First, fixed size. The size of the hash table cannot be easily changed once it initializes. Collisions. Collisions can negatively impact performance, especially with high collision rates. Security risk. Hash function can be vulnerable to attack potentially and data breaches. Application of static hashing. First, databases. Efficiently stores and retrieves data in database systems. Second, caching. Improves performance by storing frequently accessed data in memory. Third, hash table. A fundamental structure programming languages and the hash memory. Limitation and drawbacks. What we have learned in this topic: limitation and drawbacks. First, fixed sites. Second, collisions. Third, security risk. Advantages of static hashing that includes fast access. Second, efficient search. And third, optimal performance. Chaining versus open addressing. What is chaining? Simple to implement, efficient for high collision rates, requires more memory for linked list. Open addressing can be more complex, may experience performance degradation with high collision rates, requires memory. Collision resolution technique. First, separate chaining. Second, open addressing. Third, choosing the right technique. Separate chaining. This approach used linked list to store data elements that collide, allowing multiple elements to share the same hash index. Second, open addressing. This method involves searching for an empty slot within the hash table when a collision occurs, using probing technique to find an alternative location. Choosing the right technique. The selection between chaining and open addressing depends on as expected data size, dataset, and the size, collision frequency, and performance efficiency. Hash tables. What is hash tables? Which includes data structures, speed, and keys. In which data structures? Hash tables are a data structure that uses hashing to organize data for efficient access. Keys are used to calculate hash
values which determines the location of data in the table, and the speed which includes the hash tables offered fast average case performance for operation like searching, insertion, and deletion. Static hashing concept, which includes the fixed size and the key value pairs and the direct access. Static hashing utilizes a hash table with a fixed size, making it suitable for a situation where the dataset size is known beforehand. And the key value pair, which includes data, is stored as key value pairs, where the key is used to calculate the hash value, and the value is the actual data being stored. And the direct access, which includes static hashing, allows for data direct access to data by using the hash value into the hash table. Hash function and collision, which includes the three functions: the hash function, collisions, and third, collision handling. Hash functions are algorithms that generate hash values from input data. Second, collision occur when two different input values generate the same hash value. These are unavoidable. Third, collision handling. Efficient collision resolution techniques are essential for maintaining the performance of hash table. And the first one is what is hashing, that we already explained in our presentation. And what is the hashing? The key concept and the uniqueness. Hashing is a process that converts data such as text or numbers into a fixed length hash value. Uniqueness: this hash value act as a unique identifiers, making it easier to retrieve and compare data efficiently. And introduction to static hashing, which we have already covered. Hash tables, chaining versus open addressing, advantages of static hashing, limitation and drawbacks, which we already concluded, which include the fixed size, collisions, and the security risk. What is the fixed size? The size of the hash table cannot be easily changed once it initialized. Collision can negatively impact performance